For this video, we're actually looking at just introducing the idea of a graph slope and what would that look like if we drew it. So I've got three different examples. I have something linear, something quadratic, and something else. So for this one, if you look at the graph's slope on the blue line, I know a couple of things about it. One, it's constant. The slope is not changing, so I'm going to write constant down. The second thing about it is that it's going up from left to right. The graph is going up from left to right, so I know that the slope is positive. Now imagine I took these two things, something that is constant and positive, and I wanted to draw a graph of that. So constant means it's not changing. So I'm going to say that my y values are not going to change. My y values are going to be constant. My y values are also going to be positive. So when we draw the graphs here, the slopes from this graph will become the y values for the graph I draw. Now I didn't put a scale on this on purpose. I just want you to get the general idea. So this is a constant positive slope. So I would draw something constant, meaning not changing. The y values are not changing, and it's positive, meaning above the x-axis. So this could represent the graph of this graph's slope. So you could call this a graph of f of x, and so the way we're going to mark that when we actually study derivatives later would be f prime of x. This is the slope of f. It gets a little bit more complicated when you get into something that bends. So this is a curve, not a straight line, and the slope is not constant. It's ever changing. So if you look over here on the left-hand side of the graph, the slope is positive. But right about here, a little to the right of the y-axis, the slope becomes zero. It flattens out. You can imagine if I draw a tangent line over here, it has a positive slope. Over here, it's a zero slope. And then on this side, it's a negative slope. So what that means for my y values over here is that they are going to start above. My y values are going to be positive. Then on the far right-hand side, they're going to be below. And then right here where it's 0, they're going to be on the x-axis when y equals 0. So the 0 happens a little to the right, so I'm going to put that here. And then my graph is going to start above and end below. So it will go through the x-axis at that point. Now if you notice, the slope actually gets steeper as I go to the left, so my y value should get higher. As I go to the right, it also gets steeper. If this was a true parabola, it would anyway. So my y values will also be greater in magnitude, but they're negative. So I'm going to draw something where the numbers go up as I go to the left and down as I go to the right. So if I called this g of x, then I can't relabel this g of x. It's not the same thing, so I'm going to call it g prime of x. So what if we have a whole bunch of hills and valleys? Then I'm going to have a whole bunch of times when the slope changes direction here. So the first thing I usually do is I go mark all the places where the graph has a zero slope. So right here we have a zero slope, and a zero slope. When it's 0, I know that that's going to be on the x-axis. So that happens a little to the left, a little to the right, and then farther to the right. So that will happen here, here, and then farther to the right. Now before the first 0 slope, my slope was positive. Positive means that I'm going to draw the graph above the x-axis. This was on. Between these two, my graph is going down from left to right, so it has a negative slope. So that's going to be below. So I know I'm going to start above and go below. After this, I have a positive slope again, so I'm going to go above, on, and then below. Now polynomials work out kind of nicely here. As I go to the left, it gets steeper and steeper and steeper. The slope gets steeper, so my number should be higher. And you can see that I'm going down, so I would go down like this. To the left, they get higher. Between these, I've got to be below, but it's got to come back up and actually hit this point. So what I'm saying is that my slopes are negative from here to here, and you can see that they are negative from here to here. But look, as you get closer in, as I come in this way, it flattens out some, so my slopes are closer to 0. Over here, the graph is flattening out some, so my slopes are closer to 0, which should make sense. I'm going to go away from 0, back to 0, closer to 0, closer to 0. Between these two, my graph is always going up, but I'm flattening out here and here. So I'm going to be close to 0, further away from 0, close to 0. Close to 0, further away from 0, close to 0. And then finally my graph is actually negative and the slopes are getting really steep, so further away from 0. And again, there's no scale on this, so this is just the general shape of the graph. So if we call this h of x, then we would call this h prime of x. And what we're doing is just drawing the slopes of the previous graph. And that's the general idea if you're trying to look at slopes graphically without any equations at all.